Hello and welcome back to College Algebra, MAT 150. In this lecture we will be discussing the basics of solving radical equations. So any real number a and b and in an integer n, so real numbers are just any number we can think of, and integers are specifically like 1, 2, 3, 0, and -1, -2, -3, so no decimals anywhere. But then if that's the case with all those things, if a equals b, then you can raise each side to the same power. Okay? So to the integer power. And basically, what is the point of this? Well, because of this truth, so basically if you do something on one side, you can do it to the other, that sort of idea that gets reinforced, then the whole point of this is that we can get rid of radicals to help solve for radicals. And we can do this because radicals can be written as fractional exponents, and fractions times the denominator gets rid of the denominator, which gets rid of the radical. So, so basically, how do we pick what we raise everything to? We pick the index. So we're going to do a couple really quick examples that will also be illuminating to an extent or another. And we can see if this will help us solve, right? So, so find all solutions, and we have to also check. So let's do this. So what is the index of a square root? So the index is the little number that's written there and the little divot. But in this case, there is no number. But if there's no number, we assume it to be 2. So how do we get rid of a square root? Well, we raise both sides to the power of 2. And then what is the square of the square root? These cancel, and we're just left with x. And what is 2 squared? It is 4. Now, is x equals 4 a solution? Well, if we plug it back in, does the square root to the original problem? So we check. Does 4, the square root of 4 equal 2? Well, the square root of 4 is 2. So does 2 equal 2? Yeah. So x equals 4 is a solution. All right, what about this one? What's the index in this case? Well, it's the number inside the divot, and this is a cube root, so we're actually going to raise everything to the third power. And what's 2 cubed? Well, 2 cubed is 2 times itself, so 2 times 2, then times 2 again, so 2 times 2 is 4, times 2 is 8. The cube and the cube root cancel out, and we're left with x equals 8. What do we have to do? We should check our solutions. Just a good idea. And we check this by what's the cube root of 8, or cube root, excuse me, of 8. Is it equal to? Well, what times, so the cube root asks what times itself equals 2. Well, 2 times 2 times 2 times 2 is 4, times 2 again, 3 total times, is in fact 8. So the cube root of 8 is 2. So that checks out. So x equals 8. All right, so now, again, we're just doing very simple equations. There's nothing. We just have one side as being square rooted and the other side is just a number. And by the way, if you're trying to solve, that's what you're trying to get down to, just a radical on one side, so that we can raise each side to the power, so we can get rid of the radical. What about this next one? Well, it seems similar to number 1. So it's a square root, so what do we have to do? We have to raise everything to the second power, because again, there's a little invisible 2. In the divot there. So that's the index is 2, so we raise it to the second power. And then we raise -2, all of -2 to the second power. The square of the square root is just x. And what is the square of -2? Well, -2 is, so -2 squared is -2 times -2, which is positive 4. Okay, so now we need to check. When we do, let's plug it in. So the square root of 4, does that equal -2? Well, the square root of 4 is 2. Does 2 equal -2? It does not. So is x equals 4 a solution? It is not, and there are no solutions. All right, so we have all this. Now Let's try the last one. So also similar to, so 4 is similar to the third one, or 4 is similar to the second one, in that we both have a cube root. So we're going to take both sides and raise it to the power of the index, which the index is 3. So negative 2 to the third power. But this is where this starts to differ. What is the cube root of the square, the cube of the cube root? That's x, so that's fine. But negative 2 cubed, negative 2 times negative 2 is 4, but then times negative 2 is negative 8. And we've seen what the negatives of square roots can do, but what about the negative of a cube root? Can we even talk about that? Well, again, what does it mean to be a cube root? Does the cube root of negative 8 equal negative 2? A cube root says, hey, what times itself 3 times is equal to negative 8? And we just saw negative 2 multiplied by itself 3 times is literally negative 8. So the cube root of negative 8 is negative 2. Because negative 2 times negative 2 times negative 2 is negative 8. And does negative 2 equal negative 2? It does. And this further emphasizes why the cube root, it works so you can deal with cube roots having negative outputs but not square roots. Because what times itself is a negative? There's no number times itself is a negative. All right. That concludes this lecture.